This can turn pollution into fuel. Let's talk about hydrogen. All of those countries are consuming hydrogen and those are importing it. So this means it's something worth looking in. When hydrogen and oxygen are burned together, energy is released, which can be used to power a motor or a turbine. The only byproduct of this process is water. This can be done using combustion chamber or the more efficient hydrogen fuel cell, which makes it the dream fuel. However, there are some obstacles that are manageable and can be solved. For hydrogen to be usable, it has to be pressurized in tanks at 700 times the atmospheric pressure. Water is required to make hydrogen, which could compete with our fresh water demands, drinking, irrigation, and so on. Furthermore, to make hydrogen fuel cell, rare metals such as iridium or platinum are needed, which increase the cost of the hydrogen fuel cells. Moreover, this technology has difficulty in cold weather because the water exhaust freezes into ice. Also, hydrogen can seep into the walls of the storage tanks over time, causing them to become brittle and weak. Finally, hydrogen in itself is great. However, to produce hydrogen, you might use electricity that is generated from fossil fuels, which is not environmentally friendly. But not all hydrogen production is associated with bad emission. It depends on the source. A color code is used to track that depending on the source. For example, blue hydrogen is made from natural gas. Green hydrogen is made using electricity generated from renewable energy, and so on. Despite these challenges, hydrogen is still a promising technology, with fuel cell efficiency increasing exponentially. So what if we can produce hydrogen without bad emission, using wastewater and generating other valuable output as a bonus? This hydrogen should be referred to as golden hydrogen. So how can we produce it? The answer is in algae or cyanobacteria. These microorganisms are grown in a controlled environment like a photobioreactor, providing the necessary nutrients and other optimal conditions for growth. These nutrients are consumed by the cells and multiply. Then, to induce hydrogen production, nitrogen is deprived from the media, triggering the expression of enzymes responsible for hydrogen production. Finally, hydrogen is collected through a specific membrane like a filter. The yield of hydrogen from microorganisms is still small, so large bioreactors are required. One possible scenario involves using raceways filled with brackish or seawater on a vast, unusable desert lands to produce hydrogen and biomass. The resulting energy can be stored in large tanks and used to power fuel cells on demand while purifying wastewater. That's just me imagining the future, peaceful, with clean energy from cyanobacteria. And I will not talk about generating hydrogen on Mars this video.